Hey Rock Buds, it's Rock Papa. I hope you guys are doing well. It's December, one of my favorite months down here in Georgia. Today we're going to talk about the many faces of calcite, calcium carbonate. Calcite, along with quartz, is one of the most abundant minerals in the earth, and we're going to look at how it forms and some of the many versions of it that we find in the world, such as Mammoth Hot Springs in Yellowstone and several others. So stay tuned, and if this video is helpful to you, please subscribe. Thank you a million to all you wonderful subscribers. I appreciate you so much. Think about you all the time, and I wish you lots of luck and send you good, happy vibes when I do. So here we go, the many faces of calcite. Calcite is calcium carbonate, made of calcium, carbon, and oxygen. So let's find out where those elements come from that make this calcium carbonate stuff. Believe it or not, calcium by itself is a silvery white metal. Calcium likes to form ionic bonds with other elements. Most of the calcium that gets into the environment comes from intermediate and mafic volcanic rocks. Volcanoes erupt calcium-rich andesite and basalt lava flows that cover hundreds of square miles. Rainwater and snow melt pick up the calcium that's eroded from the basalt and andesite lavas, washes it down into the oceans where it mixes with carbon dioxide to form calcite, calcium carbonate. So, what is carbon dioxide and where does it come from? When you pop the top on a can of Coke, that fizzy stuff is carbon dioxide. The biggest producer of carbon dioxide in the earth is volcanoes. The world's forests also produce massive amounts of carbon dioxide as a byproduct of photosynthesis and respiration. Forest fires contribute their share of carbon dioxide too, as well as the processes of decomposition of organic material. And it goes without saying that the burning of fossil fuels by mankind creates a whole bunch of carbon dioxide as well. The biggest recipient and storehouse of carbon dioxide on our planet is the world's beautiful oceans. And it is in the oceans that dissolved calcium from volcanoes combines with carbon dioxide to form calcium carbonate or calcite. Many sea creatures pick up that dissolved calcite and incorporate it into their structures, like corals and scallops and other shell creatures, not to mention the shells of crabs and clams. Which brings us to one of the most beautiful forms of calcite, pearls. Yes, pearls are made of calcite, and they come in various colors and shapes and sizes. When an irritant, like a piece of shell or a parasite, gets into a clam or oyster, they surround this bit with calcite and aragonite, which is another form of calcium carbonate, building up layer upon layer to form beautiful pearls. Hey guys, now let's look at what happens to the bodies of all these shell creatures when they die. This part of the beach, which was once underwater, is made of sand, but it's also made of billions and billions of pieces of shell, calcium carbonate. The calcium carbonate shells of dead sea creatures fall to the bottom and get compacted to form limestone. And as you guys know, calcite is a base, and even a weak acid will make it fizz and dissolve it eventually. There are lots of massive layers of limestone all over the earth. Much of that limestone is exposed, but even more of it is covered over by layers of other rocks like sandstone and shale. And here's a picture of the Mauve limestone laid down in Cambrian times near the bottom of the Grand Canyon. And here's a picture of the Madison limestone laid down during the Mississippian time that covers a whole bunch of the western United States. And here we have chalk, which is a form of limestone that was deposited during Cretaceous time. Actually, Cretaceous means time of chalk. If there are big pockets in limey mud that's turning into limestone, over the eons as it turns into limestone, really big calcite crystals like these can form. What a paperweight. Metamorphose limestone and you get another beautiful form of calcite that we are all familiar with. That's marble. Marble is found all over the earth, including at the top of Mount Everest. Since marble is calcite, which is a base, just like limestone and dolomite, acid will make it fizz. Dolomite, also called dolostone, is calcium magnesium carbonate, and it forms when limestone or calcium carbonate is enriched with magnesium, which combines chemically with the limestone to form dolomite. This is the Bighorn dolomite laid down during the Ordovician period, and it covers extensive areas of Wyoming and Montana. And this is the Silurian Lockport dolomite that forms the hard shelf over which Niagara Falls flows. Water, which is a weak acid, flows through the layers of limestone, eating away the calcium carbonate to form karst topography, which includes caves. And that brings us to a very lovely form of calcite. Stalactites and stalagmites form fantastic shapes in caves as calcite-laden water over eons slowly dripping from the roof of the cave forms drip layers that grow into these elegant shapes and colors. Aragonite, which is another form of calcite, creates needle-shaped formations in caves like these. Carlsbad Caverns in New Mexico is famous for its aragonite. Hey Rock Buds, now let's look at another form of calcite called travertine. Hey Rock Buds, this is Mammoth Hot Springs in Yellowstone National Park, and it's unique among all the hot springs because it alone is underlain by a layer of limestone. Water heated boiling hot by the Yellowstone volcanic hotspot seeps up through the limestone, picking up calcite, depositing it in layers that build up over time, and we call these calcite layers travertine. When these travertine deposits form in cold water springs, they call the resulting travertine tufa. Here's some tufa from the Falls Ridge Preserve in Virginia. And here's some lovely tufa pools you can find way down in the Grand Canyon in Arizona. Now, what do bird eggs have to do with this video? Everything, because the shells of all bird eggs are made out of calcite, calcium carbonate. And why do birds make their eggshells out of calcite? because calcite makes a good, hard, protective covering for the embryo and also provides calcium in the last stages of development of the little birdie, and also calcite is abundant and so readily available for mama bird. Hey, most excellent rock buds, this last example of calcite is one of my favorites, and I think you will like it too. We're talking about Icelandic spar, the mysterious crystal that it is believed that Vikings used to locate the position of the sun even on the cloudiest days. The Vikings were able to find their way in the roughest of seas and on the cloudiest of days using Icelandic spar. They sailed all over northwestern Europe, the Mediterranean, the British Isles, and even came to Nova Scotia in North America. Icelandic spar is calcite crystal. They call it Icelandic spar because it was first discovered in Iceland. Hey, rock buds, the way you use Icelandic spar to find the sun even on a cloudy day is by taking a calcite crystal and putting a black dot on the backside of it. Then you hold it up to the sun and rotate it around the horizon back and forth. And rather than try to explain that process, I'll let someone from YouTube show you.
So where the sun is, where they're equal. If I go further up, one side goes dark, you go towards where the sun is, and then they equal up, you go the other way, and the other one goes dark again. As you get to the sun, they come equal, and that's how the sunstone works.
All right, most excellent rock buds, that's it for the many faces of calcite. Thank you so much for watching, and I hope this was useful to you. If so, please subscribe. And this is your Rock Papa saying happy rock hunting. Papa out.